Now what we want to do is roll a dice, and we want to store that information. So it's going to change our program a little bit. So what I'm going to do is I'm going to keep this information though. I don't want to just throw it out because I've found it's going to be useful for us later. So I'm going to just highlight all that, and there's actually a little block comment up here. And I'm going to click on that, and it's going to block all that out. I can also, I'm going to press enter, I'm going to push it down a little bit. Okay, let's roll a dice. So var n dice face is going to be of type number. And we want to roll that. So n dice face is equal to, and we need maths.random times 6. Now we know that gives us a decimal point and answer, so we need to round that. So we need to go maths.ceil and that becomes dice face. So once we've done that, we want to trace n dice face to make sure that that's outputting correctly. I can actually give this program at the end, so it's quite alright, so you don't have to type everything out. So at the moment it's rolled a 4. If I run it again, it's 6, 1, etc. So I've got 1, I've got 6, and numbers in between, no zeros, no 7s. So I know that my dice roll program is working correctly. Alright, what do we do with that? Well, we need to now store that. Now there's several different ways we can do it. We can go if bracket n dice face equals 1, then a dice faces. Does anyone want to finish that line of code for me? What do I have to do? Alright, I want to write a program so every time the dice is rolled, it stores the result of the dice face. So if a 1 comes up, I want to add 1 to 1. If a 1 comes up again, I add 1 to the 1 again, so now it becomes 2.
You want to make it store it
in the
one box, but how would you do that?
So I need to reference that pigeonhole, don't I?
Oh, so is that the bracket 1?
That's the one. So what I've got to do is, if it's a 1, I want to increment the 1 spot. So in the pigeonhole where it's 1, 2, 3, 4, 5, 6, or 0, 1, 2, 3, 4, 5, 6, I want to reference that first position, number 1. So I need to use a square bracket and 1. So I'm talking to that box. And that's going to be equal to, and if you wanted to, you can actually go itself, plus 1. So we can do it in an if statement like this. But there's always a problem with this though, and I'll just replicate this down because it's a quick way of doing it. It's not a very good way. It's sort of like a C standard sort of way of doing it, but we'll talk about that in a minute. There's a problem with this program at the moment. Normally what you find, if you declare an array, I said before, it opens up the memory space and doesn't actually really do anything for us. Normally the program will chuck in a random bit of junk in there. It could be a character, a symbol, or some sort of identifier to keep the memory space open in the computer. And that has to be a physical thing. Because you've got to remember, memory is AND and OR gates on a chip. It's got to keep a charge going through there, so you've got to put something in there. So it's a good idea to actually initiate or initialize your variables. So that's where I'm going to take this. And I'm going to, before I roll the dice, I'm going to put a function init. Oh, well, it's not actually a function at the moment. But I want to initialize a variable. So for I equals 1 to 6, I equals I plus 1, dice face isn't going to be equal to I, but I'm going to set it to 0. Then I want to trace a dice faces. Okay, so that should now give me all the zeros, and it's given me a 6. Why do you think it's given me a 6?
Since there's a mention in 4,
Because it's you tracing the end dice first at the end.
What should it be tracing?
A dice.
That's the one. So when you're looking at it, the reason why it's giving me the duplicates and all that sort of stuff is because I'm actually tracing out the wrong variable. So that's some other things you've got to be aware of, because all of a sudden you go, hang on, my output's wrong. I know in my head that I should be getting zeros, or at least a 1, because it's only rolled the dice once. So one of those counters should have 1 in it, and I wasn't getting any of them. I got a 6. So I was getting the dice roll. So in my dump of my array, what number just was that rolled dice? With the program, if it rolled a 1, a dice face position 1 equals a dice face, which we set to 0 plus 1. So it didn't roll a 1, what did it roll?
Who is that looking at zeros?
Well, look at the position. Where's the 1 appeared? In the 3. Because we don't use 0, so what position in our array did it appear in?
is the computer trying to talk to you?
So,
binary?
no. If I run the program again, I don't know if it will give me... Okay, let's... Okay. In the first run through, the 1 appears here. In the second one through, the 1 appears there. So what roll did it... What number is appearing? What dice number?
Is it actually each of the pigeonholes or something?
Yeah.
Each.
Now, in the first one, you notice when I initialize my program, let's bring that back up. I'm initializing from 1 through to 6. So that's why in the first, there's nothing, then a comma. That's position 0. Because remember I said to you the array start at 0. We're not using 0. That's why you've got a comma there and nothing before it. So in this first runtime through here, what must have it rolled? Position 0, position 1, 2, 3, position 4, position 5, position 6. So it must have rolled a 5, because n dice, if that's equal to 5, then a dice faces, my array, in position 5, equals itself plus 1. Itself is 0, add 1, it's 1. Second time I run my program, because you've got to remember we haven't looped it yet, we'll do that in a second. Second time I run the program, what number must the dice face be? The second one's the very last line. Second time I run it. What do you reckon the dice face was?
Oh, that's a 1.
You think it's a 1? Because if it's a 1, then n dice face 1, the position 1, not 0, which is before the comma, equals the n dice face plus 1. All right, let's see if we can make more sense for you.
But you know, mine came out as a 4 instead of a 1.
And make sure you got a dice faces, and make sure you're tracing out a dice face at the bottom.
That's what I've done.
But if you keep running the program, that in the 5 spot it doesn't go to a 2, so is that
Yeah, because at the moment the program runs once. I've got to
Oh,
loop.
you gotta loop that.
I've got to loop this now. So that's what I'm going to do now. So I'm going to put a loop in there so it keeps doing it. And I can't sit there and keep going command enter, command enter, command enter, because every time I run the program, it initializes the array. It turns it all back to zeros. So now what I want to do is loop afterwards. So what I'm going to do is I'm going to loop. I can use. Yep, I can recycle I. The reason why I sort of hesitate with that is because when I go I've got to check that I'm not using I within where I'm going to loop. Because if I have I and I'm indexing I and then I use I again and recycle it inside the loop, increment this by 1, and then I reset this one I equals 1, this might go to 2 and this goes I equals 1 and puts it back to 1. And all of a sudden you get this infinite loop running and it can be rather nasty. So always, if you recycle a variable, make sure you check you're not going to kill yourself. So I equals 1, capital I that is, equals 1. While, let's do it 100 times. I is less than or equal to 100, semicolon, I plus plus, close bracket, open brace. I don't want to trace the array until the end. Do I want to see what the dice face is? maybe. All right, we know that's initializing, so we'll move that up. We don't want to see that initialize every time or show us the zeros every time. We might want to see what the dice face is before we roll again, so I'm just going to trace that out. Just so I know, I should get this list of 100 numbers and then I'll get the summary. Okay, in theory, that all should work. In theory. Contains syntax error and cannot be auto-formatted. Fix the error. Can you give me where the error is, please? Okay. For I equals I bracket I is equal to less than 100, so colon I plus plus brackets brace. That looks all okay. Why are you yelling at me? All right. Here are all the numbers. Here's my array. It's been initialized. It rolled a 6, 6, a 5, a 2, a 1, and it goes through. And apparently there are 15 1s, 18 2s, 10 3s, 19 4s, 17 5s, and 21 6s. Not bad. Rolled a lot of 6s. Let's run the program again. Okay.
So more 5s.
So yeah, in this one here, lots of 5s. Now that's for 100 spins. Now this sort of program, when you're doing statistics back in year 10, you had to do the dice rolls. And they're like, roll the dice 200 times. Well, it's easy if you've got a program like this. Because I can sit there and go 200 and go Command Enter. There you go. That's how many I've got. Alright. Now, at the moment, we're dumping the array. I'm not really happy with just dumping the dice arrays. So this is where I prefer to traverse them. So what we do, we just cut this out of here. We'll move that up here and just go */. Turns that code back on. And I'll just get rid of that one. So I'll move it up as well. That way it looks a little neater. Move that up to here. We should be able to format that. Still saying there's an error. Alright, so that now should give us a nice little summary data. Oh, what happened there? Let's go back. For I equals 6, no, we don't want 6 down to 1. Let's go for I equals 1, for I is less than or equal to 6. I equals I plus, we don't want to count backwards. So we got 38, 36, 18, 37, 35, 36. So the 2's the last processing. So what we can do, we can quote. So this is where we're starting to format information. So trace I. So what we're going to do is do a compound statement. Trace quote number of quote plus I plus quote space equals space quote plus. Hopefully that all works nicely. So number of 1s, 36, number of 2s, 38. Alright? And like I said, what I just did then was help the clarity of the information. I put a line, and then I went, oh, hang on, I can compound that as a statement just to make it really clear to someone. So that's, if we wanted to, we can work out how many spins there are as well. We can actually sum up the total array and things like that. We'll look at that a little later. But that's how quick it does 200. Let's do 1,000. That's how long it takes to process 1,000 dice rolls. So it doesn't take long at all. It's a click, and it's about a second and a half to do that. So then when you start going up to like 10,000, you imagine if you had to roll a dice 10,000 times. Alright, you'd be sitting there forever. But the power of the computer, and this is what they're looking at, is like that's 10,000, that's 1,000,000. A little bit more processing time. But that's how many rolls there are. What do you notice about the difference between those numbers?
They're getting bigger every time.
They're getting bigger, but look, statistically, if it was a math lesson, look at the separation. They're pretty similar. So that's a million dice roll. So that, you know, they sort of say, well, what's the chances of 6 coming up? Just as good as the chances of a 1, because there's over the longer you play, the more chance it gets. So that's a million. Let's look at 2 million. It just takes a little longer to process. All right, that's all. So it's rolling it 2 million times. There it is.
But
You know.
start with 3.
Yeah, 33,000. You know, or no, 332.
All the first 2 numbers are 3s.
But when you're looking at how many million did I just roll it?
2.
That's nothing out of 1,000 is nothing out of 2 million. You know, so there's a pretty small chance. But you know, in like year 10 maths, you're sort of trying to talk about statistics and, you know, all that stuff. But once you get to see it happen, and that's the power of the computers. Now, this program is using an array. Like, you look at it, all my dice faces are located in one spot. I don't have dice face 1, 2, 3, 4, 5, 6. I don't have this massive list. It's all there. If I want to add them up, let's find out the total. I'm going to recycle this. Okay, I'm going to just paste this. How do I add them all up?
What? Add what up?
How do I get that to happen?
You do a dice face 1, add that, all that text.
Yeah, you can do that. I dice 1 plus, and I'm just going to copy and paste this. 2, 3, 4, 5, 6. Not that I can see them, but we will change them. Expecting right space before the parent. Quote. Might actually have to put that in a bracket. Move this so I can see what's. Oh, there we go. There was an extra plus sign we didn't need. Oh, I've got it 6 times, which doesn't help.
Number of rolls?
Yes, 2 million, 2 million, 2 million. Well, actually, I don't need the for do loop. I just needed the that trace statement out of it. So I'll ditch all that. So what I've done then is I've actually used that. I could actually put a for do loop in there and add them up through a for do loop, but I don't think it's worthwhile for this example. So we can now trace out how many rolls there were. Total number of rolls, 2 million.
To start manipulating